Hello there. Good morning, good afternoon, good evening, and if you can't sleep, good midnight. So, what we'll be talking about today is just a simple project. This is going to be a very quick video, and it's about segmentation. So, in this case, it's just going to be some customer segmentation of some data that I got from Cargo, and it's a mall data of customer transactions and things like that, or customer data. So, what we usually do in segmentation is we have something like this. We have two classes, and let's say one class is here, and let's say another class is right here. So we can see that when we have something like this, it belongs to this one here. And when we have something like this, it belongs to this one here. So basically, if when you're looking at some customer data, you tend to see, um, just hypothetically speaking, now you tend to see them having one or two, okay, let's even say probably three types of classes. So they either belong to one of these three, and in some cases, you might have some outliers, but not necessarily in this case. But in most cases, a customer usually belongs to one of the different types of classes. So for this one, what we can use to do this kind of segmentation task is using the k-means clustering technique. And it's a very simple technique. It has its own limits, but it's still a very, very, very useful technique that's used in a lot of applications. So, without further ado, before we go right into the code, I'm just gonna quickly brush through it. And let's say, for example, I have a number line right here, like this, and I have these points: two, one, two, and this one here, one, two, three, four. Okay. So with the normal human eye, if you tell me what are the three classes of points that we have here, you can say this is point one, this is two, and this is three. That's just us determining what classes that are, just looking at it normally. But if I want the computer to do this and I want to use k-means clustering, it works like this. So I have all of these different points over here. And what the algorithm does is to pick three random points. So let's say, for instance, it picks up one, it picks up two, and it picks up three. So this is just hypothetically speaking now, right? So what it does is it takes the distance from all of the points to each of these clusters. So we call this one, just put here so it's remembered. So this is known as a cluster. That looks ugly. So I can say this one right here is our cluster. Okay. So what I'm going to do in this case is, now looking at this point, I'll take the distance from here to here. I'll take the distance from here to here, and I'll take the distance from here. Oh, sorry, that should have been earlier, to this point here. So I take the distance from this point to each of the clusters, and what I do is I say, okay, what's the closest cluster to you? And definitely it's not this, it's not this, and I can see that is this one. So if I say that this is closest to this and this become one. This becomes part of this cluster. And let's say I had one point here, for example, and I take the distance from here to here, here to here, and here also to here. You can see that this is also the closest, so this also becomes part of this one. So let me just get down so it becomes neater, right? All right, so we can see that it's like this. So this one is part of this. And the good thing about this is, okay, not the good thing. The next step about this is that all of the data points are going to go through this process. So if I now take, let me just try another one right here so it looks a bit neater. Okay. So you can see that what we've done here, this and this are in one. All right. So like this. Okay. So looking at this data point now, I say, okay, I'll look at this from here to here, this one from here to here, and this from here to here, right here. So we can see that the closest or the smallest distance is this one right here, okay? So this one becomes automatically part of this one. All right, so like I said before, all of the data points are going to go through this process, and once we do it for these ones, you can see that these ones become part of this one. So the next part that we need to do is, once we have these clusters right here, we have something like this. The next thing, okay, let me just put the shades on. Okay, so something like this. 2, 3, 4, and the middle one was, okay, the second one here. All right, so once we've gotten those are clusters, what we now do is to calculate the average of this cluster to each of the data points in its cluster. So this one right here, let's say I get this one here as my mean. So just put this one so we remember that. So this one right here is my mean, and the distance between here and here, now this is the only one, this is the only point here. So we have this and this one right here as my mean. All right, and let's say this one and this one right here, they can see that the average will probably, let's say, be here. All right, so the average between each point and the cluster is what is going to be the one here. Okay, so the next part we need to do is to calculate this, each of the points from here to here, from here to this one, and from here to this one. And we can see that here is still closest to here. So, and when we look at this one right here, if we do this, so we had a mean here. Sorry, that doesn't look very nice. Okay, so we had here to here, and we have 1, 2, 3, 4. Okay, so you can see that for this particular point now, I take the distance from here to here, here to here, and here to here. So you can see that this point here is still coming to this one here. All right, and the same thing for this area. So at the end of the day, we don't need to change anything here. All right, so if we needed to change something, we would just needed to address the mean point, but in this case we don't have to change anything. So we all know that at the end of the day, the final cluster or the final classes that we have is just going to be like this. So basically that's just a simple explanation of what it is. So we have cluster 1, cluster 2, and cluster 3. Okay, so that's all we need to know about, almost all we need to know, but that's just a basic explanation of how the k-means work. Okay, but then you're like, most of the data I've seen is not on the number line, so it's basically the same principle. So let's say I have something like this, for example. Let's have something like this, and I have something like this here, and I have something like this over here. Okay, what happens in this case is we pick 3 random points. Just trying to use a simple example here. So I pick this one, pick this one, pick this one. So all of what I've explained over here, we calculate from here to here, here to here, here to here. And definitely we can see that this one's closest to here, this one is closest to here, here's closest to here, that's closest to here, like that. This is close to this, and this is also close to this. So we have our clusters right there. So it's basically the same principle, and that's how we go about it. Now, usually it's not like this in some instances. So, for example, if I had something like this, if I had something like this, for example, so there are some times that the randomness that goes on isn't so nice. Let's say I can pick this one as 1 point, this one as 1 point, and then this one as 1 point. So nothing was picked from here. So in those cases, these ones might have a little bit of an easier time, getting to the getting to a correct classification, but these ones might have a longer time. So the other points are not really the other random points aren't really centered around what their what their neighboring data points. They aren't really centered where the other neighboring data points are. So so I'm kind of mixing my words there. Okay. So we have this one for example, and we have this one for example. So what we do in this case is we calculate from here to here, here to here, calculate this point from here to here, and just like that. And at the end of the day, what happens in this kind of case is that we have these points have changing the centroids. So remember in the earlier explanation, I told you about these points here, this one right here, this one right here, this one right here. So because of how it is and how badly the centroid might be in a lot of cases, the centroids will move on their own, and that's when it becomes or it gets to the optimal point, and then at the end of the day, you have the centroids coming here, you have the centroids coming here, here, and here after many iterations. So basically, it's if you don't understand what I've said just understand this concept that I've said earlier, and basically that's what the whole k-means clustering is. All right, so in the k-means country, in the k-means clustering, we can see how it's able to classify the each of the data points that we have, and we have, let's say this one is let me just say rich, let me just say something like average, let's say something like poor, for example. Now just those kind of segmentations, and that's what basically the k-means is about. Now the limitations I was saying earlier about k-means is when it comes to things like this. Let me just draw an example. When it comes to things like this, it might be a bit difficult because this one tends to, it's kind of like swallowing up this one here. So with the natural eye, you can see that this is one class, and then this one right here should be another class. So let's say something like this, right? So this is one class, this is another class right here. So the best one that we can use for this kind of case is db scan. So this is the best one for this kind of thing. So but when it comes to using k-means for this, it's a bit limited. So there are other clustering there are other clustering methods that we can use, and db scan is one of the ones that we can use in that kind of situation. All right, so I would say that one will be left for another day. So let's just move on. All right, and let's go to the code right ahead. So for the code, it's just going to be a very quick one with a lot of data visualization steps. So this shouldn't take us too long. All right, so the first thing we need to do in this case is to import our dependencies, like always. And we have our numpy, pandas, matplotlib, seaborn, and right here we have our k-means clustering from sklearn. So this one right here is just to ignore some of the warnings because they actually don't make the code look very nice, to be honest. So that's why I did that part there. All right. So Next thing we need to do is to import our data, and that's this one right here. So we have a customer ID, gender, age, annual income, and spending score. All right, so just to do some EDA, see how it looks like. That's it right there. And describing it, you can see the count. So we have 200 rows, and the averages. Just ignore this. This isn't something we should pay attention to. I think I might have dropped it in the future. Anyways, so we have our age. We have the mean age, which is 38 years old, and the media or the mean annual income, which is $60,000 because of the K, and we have an average spending score of 50 or 50 there. All right, so the standard deviation minimum, and these are interquartile ranges, and this is our maximum. So you can see that the types that we have, we have our integers, and okay, these are good. Gender object, okay. So let's just see if we have any null values, and from what we see here, we have 0. And like I always say, most Kaggle data sets are usually good in this kind of areas. So next part is we're seeing, okay, looking at the customer data and the gender column, we have the male and female. Those are the genders that we have over there in the data. So okay, here I drop the customer ID column, which in place is true, so that I don't have to start assigning this to a variable, that kind of thing. All right, so looking at if it's changed, all right, it's gone. You can see that. So the next thing we're going to do in this case is just to do some visualization. And let's see, right here we have the number of male and female. So female customers are more, or female transactions are more in this case. All right, now the next thing is we have the age count of the data set, and this is right here. So this one was done with the histogram and using the Seaborn library. All right, so we have our data to be customer data, and the X is our age column right here. Okay, so nothing much right there. We can see the count, and we can see that the class of age that is the most is between 30 to 35-ish, around that area right there. So we have about, okay, we have more than 40 of them. So it's quite a nice distribution of ages. So the next part we're going to do is just to plot the gender against the annual income and the spending score, and that's what we have right here. All right, so initially I didn't put this right here, so this was giving me something else. I had to go and check the what do you call it now, I had to go and check the documentation of Seaborn to go and actually say that the data that I was having was a bit weird, because when I plotted this at first, this was just giving me 60, and then I was like, you can't tell me that 1,000 people or 200 people have only given you a value of 60. So I had to go and change this. So apparently that was wrong, and I had to make the estimator to be sum. All right, so the data here is this. Those are X, Y data, CI none, and that's our axis, and that's because we just did some subplots here, just some simple tweaking, nothing too complicated. All right, so next up we have this. All right, and I did this to get the age distribution in this case, and right here we're having the age against the annual income. Sorry about that. So having the age against the annual income. So we have our, what I did here was to create an empty dictionary. We have our counter to be 0, bin size that will be 10. All right, and for this one we're going to be looking at the annual income. All right, and how this works is we have a maximum number, which is age, and I guess that will be, sorry, so our maximum here is, where is it? Okay, so our maximum age right here is 70. So the oldest we have is 70 years old. Okay, that's our oldest customer that we have. Probably need to do some more advertisements for the older ones. All right, so we have 70, and next up, the way this works is say while this. Okay, before I go into that, what this is trying to do is I'm trying to get from 0 to 9, 10 to 19, 20 to 9. So I'm trying to do from 0 to 10 minus 1, 10 to 20 minus 1, 20 to 30 minus 1. So basically, that's why this is here, but I'll get back to that later. All right. So the total that we are having right here is to put the age values in bins with filtered values that are greater than or equal to the counter, and filtered values that are less than or equal to the counter this. All right. So this is just trying to create a range, and in simple terms, we are filtering the data set. Let's say, for example, now just looking at this first one, we're going to filter the data set by the values of age that are greater than or equal to the counter, and less than or equal to the counter. So we, at the end of the day, we end up getting something like 0 to 9. And when we get 0 to 9, we add those values together. All right. We add those values together with our sum aggregation right here, and that is what gives us this. So for 0 to 9, we have nothing, unfortunately. So this right here gives us a range, okay, and sums the values that are found in that range. So basically, that's what this line says. I think I could have made it a bit shorter, but I think we'll just go with that for now. All right. So the next thing we need to do is to append the values that we're getting. So right here, this is going to be my key value, and this is going to be the value, basically. Yeah. I was looking for another word to say, but I think that's what came into my head. So this is going to be the key, and this is going to be the value. All right. So right here we have. Okay, so we are appending that, and so we're going to do the counter plus the bin size. So basically, that's what this one means right here. So let's say for the first iteration we have 0 to 9, and then for the second iteration we're going to do counter is equal to the counter plus the bin size. So that will be equal to 0 plus 10, and then the counter now becomes 10. So this is going to happen. This is going to keep on repeating itself until it gets to the maximum number, which in this case will be 70. All right, as we've seen right here. So this is 70 right here. So you can see it's only going to do this till 70. And once it's going to do to 70 right here, it's going to happen for 70 to 79. And once this has gotten to 70 to the 79 range, this is going to be 70 plus 10, which is going to be 80, and that gives a false result for this, and then our loop ends. So that's just the basic working behind this. And when we do the bar plots, we have an exit list equals to list of this and this. Before I tried doing this without the list function, but it seemed like I needed to actually put in that part, so that's why that is there. I think Seaborn's more friendly with this rather than just feeding it the keys and the values directly from our dictionary. All right, so this is just to beautify, and this is just to beautify. If this is not there, it's not as fine or as beautiful as it can be. All right, so the next part we have is our scatter plot, and we're just going to do the annual income by the spending score, basically. So you're going to see a cluster right here. You can see a cluster right there, and this is just because these are two numerical variables, so scatter plot is the best for that one. All right, so remember from here when we talked about this. Just trying to pick up the parts. Okay, so here, for example, we have these three clusters, and what we can see here is, okay, we have a cluster 1, 2, and 3. So in some cases, you might ask why isn't it just two clusters? So the reason is usually there are optimal number of clusters, and in most cases, trust me, we don't really know what the optimal number is until we actually see the result. So the best way of seeing the best number of clusters in this case is to do something called the elbow method. I'm sure a lot of you will actually be familiar with that. So, but for those that might not know, I'm just gonna quickly run through it. So for this one right here, just gonna quickly bring that up. So this is what we have as the elbow method, and you can see here this is the amount of clusters. We have 1, 2, 3, 4, 5, and for here we have can see that the optimal number of clusters is probably 4 or 3. So let's see. Can't remember which one I went with again. Okay, I'll get to that part later. All right. So we have the optimum K, and the column one is age, and the column two is annual income, and we have our WCSS right there. All right. So, and what I'm doing is basically I'm saying, okay, for this particular data that I have, I want you to do, I want you to perform the K-means algorithm on them, and I want you to do the K-means algorithm for this range, with the K being from 1 to 10. I want you to do it when K is 1, when K is 2, when K is 3, up to 10. And I want to know the best value for K for this kind of thing. So basically, that's all we're doing here. It's not anything too serious. So we can see here that a lot of people might choose 3, some might choose 4, but the optimal number in this kind of case, when it is plotted, is either 3 or 4. Okay, so we have fit. So okay, let me just start from here. Sorry, we have the K mains object right here, and we're defining that. So number of clusters is for you to understand this one, you can just check out the documentation. So we have number of clusters here is kval, and you can see that this is what is going to be iterated. Random state, this can be anything, and this is also our init stat right there. Okay, so we have our k means, and we're saying do this for 1 to 10, and next thing is we're going to fit in our data, and our column 1 is age, and our column 2 is our annual income. So I'm just using 2 columns. You can use more than 2 columns, to be honest, for the k means, but just for visualization sakes, we're going to focus on the age and the annual income columns right there. Okay, so first thing we're going to do is we're going to fit this into the k-means, and we're going to get the values into our empty list over there. All right. Okay, and just to keep checking what k-means inertia means again, just to show you what it does for us. Okay, so I'm just gonna bring that up. Let's see where inertia is. Okay, so you can see the sum of square distance of samples to your cluster center weighted by the sample weights if provided. So you can see this is sum of square distances of samples to your closest cluster center. Okay, so basically that's what the inertia is doing for us, and we can see here we have the SSE, and this is, you can see it's reducing, and I think the lower it is, the better it is. So that's why in this case we have 3 or 4. Now you might say these are not lower, but those are more clusters, which also isn't good for us. So the best thing is just finding a good balance for this kind of thing. All right, so knowing that we can choose 3 or 4, and for this one we are choosing 4 clusters. Okay, so our customer segments right here, I created a class for this, and we have something like this after all of this code. So just to go through the code again, we have 4 clusters for the k-means object right here, and we're going to use the fits predict value. Let me just see if I can bring that up. let's see, first predict. I think I need to search that again. Okay. All right. So computer's gonna predict cluster index for each sample convenience meter equal to column fit. So basically, what this is doing for us is basically just fitting. We have our x and y, and it's fitting these into the object for us, and it's also bringing out the predictions at the end of the day. So it's basically just combining two things. So you can do fit and you can do the predicts, just like here. So you can see one's fits, and we also have the predict. So you can do both. You can do both of them separately, or we could just make our code faster and just do this. All right. So we have our values, okay, and those values are the different classes that we have at the end of the day. All right. So what comes out later is for each of the rows and for each of the data points, this gives us the class that they are going to belong to. So let's say for customer 1, it tells us, okay, it's going to be customer 0, it's going to be in the class 0. For customer 2, it's going to be in class 1. Customer 3, class 0. Customer 5, class 3. Customer 6, class 1. That kind of thing. So basically, this is what's being produced over here. All right, so the next thing is just to copy. I didn't want to touch this particular data frame, so I just created a copy of this. That's why I see that, and I created a new column called. To be honest, I think it would have been better if I had done this without it being in the class. I think that's a mistake on my side, but just gonna make this short and just quickly explain this. So we have sets, like I said, to make it beautiful, and then we're going to do a scatter plot, and the scatter plot is going to initially do all of these with the hue being the class. So it's going to basically plot everything right. Okay, all of the points is going to plot everything. Okay, and the next thing that we need to do is just set the hue as a class. Remember, the class column is what contains the class of each of the customers that they are being classified as. So once you can see right here, that's our legend right there. So you can see this one here is 3, and this one here is 0. This one here is our arrangers is 1, and here is our 2. All right. So basically, that's all this is doing. Okay, so just for you to understand the other part, you can check the scatterplot documentation, but this is just how I went about it. And the next part of this is just to create something for the centroid. Okay, so this right here is going to give us, let me just see if I can copy this one and show you. Okay, so you can see the cluster centers. All right, so this is coordinate of the cluster centers. So remember in the example I showed you, we're having things like this. So basically, when there's no more improvements to the whole process, these kind of things are going to be the cluster centers. So initially, if it's not correct, if things need to change, the centroids or the cluster centers tend to move to find the optimal place that they're meant to be. But if nothing changes anymore and everything's perfect, it just stay there. So in this case, this is one of our cluster centers. This is the second one, and this is the third one. And what that does is this is going to have a coordinate. And when we look at something like this, let's say this is one of them. Let's say this one right here is one of them. This is one of them. This is one of them, and this is also one of them. And we are going to get our coordinates on the x. So this one's right here, y. So on the x and y axis, we're going to get the coordinates of these, and that is what we are going to feed into the scatter plots. And that is what we're going to feed into the second scatter plots object over here. So that's why we have this, and this. So all of this is, to be honest, a lot of this is just the design, because when you initially plot this, this isn't actually very visible. So I had to actually specify the marker and the line width to make this bolder and make this black. Trust me, it can be a bit confusing sometimes, but it's relatively simple. It's relatively simple to work with Seaborn, and to be honest, I really prefer it to Matplotlib because of how nice it looks in a lot of cases. But Matplotlib is far more used in a lot of instances. But in this case, I'm just using Seaborn. Just a little bit of my preference there. All right, moving on. I think that's the last thing, nothing more. So we can see our customers are divided into 4 classes. And if we set this 1, 2, 3 now, we end up having just 3 of these. Oh, sorry, I forgot to put 3 there. Okay. So you can see right here we have 3 clusters. Just 1, 2, and 3. So basically, that's how we segment our customer data. And thank you very much for staying with me and hearing me talk a lot. And I appreciate you. So I've tried to, so just a brief summary of what we've done. We've seen how the k-means algorithm works. Each of the data points are taken from, each of the distance from each data point is taken from each of the clusters, which are chosen at random. And once we see the shortest distance, we assign it to the closest cluster. Once we get those clusters, we get the mean. All right, we get the average ones, and with the average or the cluster centers that we have initially, we see if there's a need to adjust them or not. And once we adjust them and get the optimal ones, we can now say, okay, this is the final clusters. These are the final clusters, and we do that for, let's say, cluster 1 when it's 1, 2, 3, 4. When the k, so I'm talking about the number k first. In this case now, we do it up to 5. And all of this is just to ensure that we're getting the right amount of Ks that we're putting, the number K. Just put it that way. So basically that's it about the K means. And when you plot this in this kind of form, you might have values that were chosen at random at very different places. So when we choose values that are chosen at good places, or in this kind of case something like this, the algorithm tends to solve this a little bit faster, because basically at the end of the day it's solved pretty quickly, and you have the centers located in the right, on relatively right places. But once they're taken to places like this, and this, at the end of the day, you tend not to have a straightforward, or you tend not to have a very quick solution, because these centroids have to be corrected. So at the end of the day, you have this one coming to here, and this one coming to here. It's had to move all the way here, something like that, and all before it gets to somewhere like here, for example, as the optimal place. So this takes more time. This takes more iterations. But basically, it's all simple. It's all simple. K-means caution isn't too intensive in a lot of cases. So, like I said, just did some EDA right here. The data is all okay, no null values or anything. And we did the elbow method right here to find the optimal number of K. It can be 3, can be 4, or depends. And right here, you can see this is, sorry about that. Here you can see the number of clusters is 3. And if I change this back to 4 again, if I change this back to 4, we can see that we have that. Sorry about that. We have 4, and I can do this to 5. So we have 5 values here. So it all depends, and basically that's just the whole summary of customer segmentation. And thank you very much for staying with me, and hopefully I see you next time. Thank you for watching.